Okay, welcome back. What I want to look at today is PowerPoint maths. Okay, now this is maths we use in the classroom, which has been paid for. Okay, so I'm hoping that by using this, giving you the opportunity to access it at your leisure, that will be okay, right? So this just tells you what we're going to be looking at, okay, and what it's meant to be doing for us. Okay. And again, it's PowerPoint maths. Okay? And this was purchased some years ago, okay, for delivering in our classes. But as you know, these things changes, comes and goes. Okay, so I hope you find this useful. Okay, and again, just make sure I've got this in view. PowerPoint maths. Okay, so we have interior angles of polygons. What I want to look at is, here we have polygon of 1, 2, 3, 4 sides. We have a polygon of 1, 2, 3, 4, 5 sides. And we have a polygon of 1, 2, 3, 4, 5, 6 sides. And we have a polygon of 1, 2, 3, 4, 5, 6, 7 sides. Okay, so we have polygons from 4 to 7 sided polygons. Okay, now what we need to look at is the angle that these polygons will go to make up and how much degrees is in each in respect of the angles when added together. Okay, so we have 4 sides, okay, 5 sides, 6 sides, and 7 sides, which we just previously mentioned. Now this is a quadrilateral triangle. This is a pentagon, but again, the main heading here still refers to interior angle of polygons. Okay, there's still a type of polygon in one form or another. Okay, hexagon and heptagon, so or septagon. Now we have here quadrilateral 4-sided, 5-sided is a pentagon, 6 sides is a hexagon, and 7 sides is a heptagon or septagon. Okay. Now, how many angles is in these in each? Now, let us see in each case. Now, to establish this, we need to look at drawing lines. Okay. So we need to draw lines that formulate a triangle. So in this some case, we may have a line drawn from here to here. We may have a line drawn from here to here. Okay. So forth. And we may have a line drawn from here to here, or quite possibly from here to here. But let's see how our lines are drawn up in order to give us the relevant angles that we need to add up to find the total in respect of the quadrilateral, pentagon, hexagon, and the heptagon or septagon. Okay. Here, our first line is drawn here. Okay. That gives us how many triangles? That gives us 1 triangle, 2 triangles. And the question here is, how many degrees makes up a triangle? Okay, so let's look at the next. Let's keep the question. So we know that here, that triangle, a triangle must add up to 180 degrees. Okay? So if that's 180 degrees and that's 180 degrees, that will give us, and I'm not going to tell you, let you figure it out for yourselves for a moment, and then let's see what we come up with. 180. So 180 plus 180 equals 360 degrees. Okay. So keeping that in mind, 180 plus 180. So we have two triangles. Okay, two triangles. 2 times 180 equals 360 degrees. Okay. Now, we want to look at all 5 sides. And we're looking at the pentagon. So we will look at the quadrilateral, which is a 4-sided figure. We're now looking at 5 sides, which is called a pentagon. Okay. So that's one triangle. Okay. Here we have one triangle here. Okay, now see where next triangle coming to. Now I would come into here, somewhere here actually, basically. Okay, so let's see if I'm right. If you come to here, thank you, it does. So my next triangle is coming to here. So we have 1 triangle, 2 triangles, 3 triangles. And we know that 3 triangles, a triangle must add up to 180. So we have 3 triangles, that's going to be 3 times 180. Okay, so let's have a look at it. Now write these out for yourselves. Make sure you understand them and read them. Okay, 180. Okay, 180. Okay, okay. 3 triangle equals, okay, that's, now we can see here 3 times 180 is 540 degrees. So within that pentagon gives us 540 degrees. Now just pan back a bit so we can make sure we get it in. Okay, now we're going to the 6 sides. Okay, and we're going to the hexagon. I'm just going to that, make sure that we can get that into plain full. Okay. Okay. We're now going to the 6 sides. Okay, and here we have so I'm going to go with an angle triangle here. 1 there, 1 there. So I'm going to look at possibly 1, 2, 3 triangles as well here. 1 triangle, 2 triangles, 3 triangles. The difference here is that all we therefore have now 1, 2, 3, 4 triangles. Okay, in this case. All right. $180, so it's going to be 4 times 1, 2, 3, 4 times 180. Okay, and there we have, for this here now we have 720 degrees for our hexagon. So in regards to a hexagon, 6 sides, it will be equal to 720 degrees because we have got 1, 2, 3, 4 triangles within that hexagon. Okay. Now let's now go to our heptagon. And again, for me, I'm going to be looking at possibly 1, 2, 3, possibly 4. So let's see if I'm right. Okay. No guarantee, mind you. It's just my perception. and I'm entitled to make mistakes like anybody else. Okay, thank you. 2, 1, 2, 3, 4. So we got 1, 2, 3, 4. We have 5 triangles. Okay, and each one is at 180 degrees. So we got 1, 2, 3, 4, 5. That's going to equal to 900 degrees. So here you can see now that our 7 sides heptagon with 5 triangles gives us 900 degrees. Okay, and that's the formula we would use every time. Okay, let me just pan back a bit so we can make sure we get it all in. Okay, and you can see how it's done. Okay, I hope you find this useful. Now write the triangles, draw out the triangles for yourselves. Okay, then do the calculations. Okay, and here we're looking at find the connection between the number of sides and the number of triangles. Okay. Okay. The sum of the interior angles of an n-sided polygon is n to the minus 2 triangles equals n to the minus 2 times 180. So whatever the number of triangles are, v minus 2, and it's equal to n minus 2 times 180. Okay. And n simply represents, you can have any number of sides. So simply we're saying that this formula would work. So if we have and it does work. Okay, when you write it out for yourself and you apply it, you'll see it works every time. Okay, thank you. Okay, let's just go up to here. I'll make sure we get this in for you. Interior angles of polygons continues. Okay, calculate the angle sum and interior angle of each of these regular polygons. Okay. So have you got this for yourself first? Okay, before. Nonagon, and know the names of each. Okay, it matters. It comes back to you. Decagon, Hendecagon. It's okay. I'm making sure that I can pronounce the decagon. Hexadecagon and icosagon. I mean, can you imagine someone being named icosagon? Goodness me. Sorry, forgive me. Right. Now, let's go back to the information before, and when you look at this, you'll see that how it actually has done it. Okay, so the previous page was the information that you need to resolve these. So use that information. I'm not going to go over it again because I'll be simply repeating myself, and that's not what this is about. Okay, so you need to write out the information for yourself, draw out the diagrams with the sides, and apply the formula. Okay. Okay, so let's get them filled in. Okay. Now let's just go back to it. Make sure that you can get all of this in. Okay. Okay. Now, what happened here? What has happened here? So make sure that you understand the concept of this. Okay. So let me see. We know it's 900 degrees. So if we take n, that'll give us one triangle, two triangles, three triangles. That'll give us four triangles. So, sorry about that. So if we take this formula, we have 7 sides, right? So what we then need to do is 7 sides minus 2, okay, equals 5 times 180 equals 900. Okay, and that will give us our 900 degrees here. Again, if you take the 9 sides, you can do the rest for yourselves a little bit. Okay, it's not that difficult now. Okay, you take 9 sides, again applying the formula. 9 minus 2 equals 7 times 180 equals 1260 degrees. And you can see that has applied, and it works like every time. So apply the formula and you cannot go wrong. Okay. And again, we're still looking at interior angles of polygons. And here we have to find the unknown angles here. So now the diagrams are not drawn to scale, okay? They're just drawn freehand. Let's call it just freehand. We know that's two angles. Okay, so the angle W should be what? So we have 70 plus 100 plus 75 equals 245 degrees. Okay. So by my calculation, W should be 115 degrees. Okay, so W should be 115 degrees. So you can see that I am correct in my calculation, because we have two triangles. Add up the total degrees, then add up the degrees you have in your polygons, then subtract it from the total. Okay, and that should be the rest for you. And again, here I'm giving you time to do these for yourselves. Okay. Okay. And again here, find these for yourselves. You can see here. Okay, I'm not going to do it just yet. Give you a chance to apply some knowledge from the previous slides. Okay. And then again, here you can do this one for yourself as well. I will put it in, but here's giving you a chance to look at these for your own edification. Let me just pan back a bit so we can make sure we get it all in. Okay. 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 Good. Thank you. I'm hoping that I can use this. Okay. Now remember, you know that's 90 degrees over there already, so you can add these up, so apply the same principle. Okay. Again, I'm leaving it here for you to find these for yourselves, stage by stage. Okay. Okay. Okay, now just have a go for yourselves. You know the angle is 90 degrees. So 90 plus 75 plus 75 gives you so much angle. Because you know it's 1, 2, 3, 4 sides. Okay, so it must add up to a given value. Okay. And let's see what we can come up with now. Okay. Okay, thank you. That's us. And let's go to the other polygon. And again, you have the same thing here. That's 90 degrees. Okay. So find Z. Okay. That's us. Okay, let's pan back a bit to make sure we get everything in. Okay, thank you. And again, looking at interior angle of polygons. Let's get this angle of polygons. Let's make sure we can get that to read for you. Okay. And get this done for yourselves, okay? All right. have a go for yourselves now. So I'm going to leave it there for a minute while you have a go for yourselves, look at it, before I put in any answers. And again, you've just done something like this again, so it should not be a problem in resolving these. Okay, thank you. I hope you found this useful. Have a good day. Bye bye.